Okay, what we'll look at in this lesson is finding probabilities of the normal curve or using the normal curve. We can find probabilities using the tables located in the back of the textbook. Okay, these are going to be the Z tables. Okay, these tables will give us the positive and negative Z-scores rounded to the nearest hundredth, and the body of the table gives us the area under the curve, or the probability, to the left of the corresponding Z-score. Okay, and then we're also going to use a calculator to find our probabilities. Okay, so find each probability by locating the Z-scores in the table and draw a graph of each. Okay, so when we look at the probability that Z is less than 1, what we're going to do is we're going to draw just a generic normal curve. Okay, label the curve Z, or the axis Z. And remember that a Z-score of 0 is right in the center. A Z-score of 1 we'll say is right about there. So Z is less than 1. We want to find the area or probability to the left of 1. Okay, so what we do is in the back of the book, okay, in table A2, okay, they're on two different pages. We have negative Z-scores, and you can see that the Z is labeled and then shaded to the left. And we see Z, and then in the left-hand column, negative 3.4, negative 3.3, and so on. Okay, those are the negative Z-scores, which means you're to the left of 0 to the nearest tenth. And then going across the top is the hundredth place. Well, we have in this one, Z is less than 1. Well, that's a positive Z-score, so we're going to look at 1 as 1.00. So our Z-score, 1.00, and again, we can notice up here on the top of the page, see how you're shaded to the left of the Z-score? Well, right now we have a Z-score of 1. So we look up 1.00, so 1.0, and then the hundredth place of 0. Okay, notice that's right there. So 0.8413. So the probability that Z is less than 1 is 0.8413. Okay, so once you get the hang of it, it isn't too bad. So at the top of the page here, when I say we're the area to the left of the corresponding Z-score, the body of the table gives the area under the curve or the probability. What we just did there, the Z-score is given in the column, and all these decimals, okay, it looks crazy, okay, but all these values in this table that are in the body of the table represent probabilities or areas to the left of the Z-score. Okay, so that's what the top of that page means. Now, using our calculator, okay, if we follow the directions, we do second vars, normal CDF. Now, you may have seen in the past, we did binom PDF and binom CDF. Okay, those were the options that we did before. Those were for discrete random variables or binomial probabilities. Okay, now what we have is we want to find a normal CDF. Now C, again, stands for cumulative. The DF is density function, which is way beyond what we need to worry about. But C means you're going to accumulate from all the way to the left up to 1. Or you could look at that as 1 to the left. All right, so we choose normal CDF, and then we put the left Z-score, comma, right Z-score. Now, when we look at the left Z-score, well, when you go all the way to the left, remember that the normal curve keeps going on forever. Okay, so there really is no smallest Z-score or left-hand Z-score. So what we do, I generally say put in negative 100, which means you're 100 standard deviations to the left of the mean. Okay, which is a long ways left of the mean. Some people will tell you to put in negative 1,000 or negative 10,000. Okay, generally it's not going to change your answer much. So negative 100, we'll put that for the left z-score, and then the right z-score is positive 1. Press enter, and we get 0.8413447. Well, if we round to the nearest 4 decimal places, notice it's the same answer as we had from the table. Okay, so if you use your calculator, I want to actually see what you put in. So normal CDF, and then negative 100, comma, 1 equals, or is approximately 0.8413. Okay, as we go through the rest of the course, we'll be able to use our calculator more and more. I think it's important to see the tables because it reinforces exactly what you're finding, right? At least I think it does. But we can get comfortable with the calculator also. All right, the next one, the probability that z is less than 2.34. So again, we're going to draw just a generic normal distribution. Okay, label it z. 0 is in the center. 2.34 is way over to the right. So less than that. Okay, we want all that area. Okay, now in our book, positive 2.34. So we'll find that. 2.3 is right here. And then this will be 2.30, 2.31, 2.32. 3.3, and then 3.4 will be this column, 0.9904. Okay, so 0.9904. Okay, in our calculator, we're going to do normal CDF. Again, we're going all the way to the left, so the left-hand z-score, we're going to say negative 100 or negative 1,000 if you want, comma, the right z-score is positive 2.34. And then if we do that in the calculator, again, normal CDF, negative 100, comma, 2.34. And we get 0.99035. So to the nearest 4 decimal places, that 5 will round the 3 up to a 4. So it turns out to be the same approximation as the table. Okay, sometimes the table may be, when you go to 4 decimal places, you may get slightly off, but they should be very close to each other, okay, just because of the rounding. Okay, I'll let you take a minute and do the z is less than negative 0.85. Okay, so I suggest you take a minute and do that, and I'll actually tell you to pause the video, and just for the sake of time, because this may take some time to get through, okay, I'll put the answer up here. Okay, so if you want to take a minute and pause the video and then do the answer yourself, feel free to. Okay, but this is it right here. Okay, and then part D, the probability that z is greater than 0.33. Okay, now this one is a little bit different because now we're looking at z is greater than 0.33. Okay, instead of less than. Remember that the z-score finds the area to the left, not the area to the right. So when you shade your normal curve, okay, it looks like that. Oops, let me cover that up, sorry. Okay, and then when we look at the probability that z is greater than 0.33, what we do is that the only z-score we have to look up is 0.33. But remember, when you look up 0.33, that gives you the area to the left of 0.33. So that's going to give you all of this area to the left. Well, we can use the complement, basically saying the idea that 100% of the data lies underneath the curve, or the area under the curve is 1. So if you take 1 minus the area to the left of 0.33, okay, notice how we went from greater than 0.33 to a less than now, because we're using the complement. So look up 0.33, and that gives you 0.6293. So we do 1 minus that, and that gives us the answer of 0.3707. Okay, on the calculator, we do the normal CDF again, but now the left z-score is not negative 100. Now the left side z-score is 0.33, and then we go to the right, so we're going to go to positive 100. Okay, so we'll do normal CDF 0.33, 100, and we get 0.3707. Okay, now again, I'm not going to spend a lot of time doing all of these. I'm just going to kind of go over quick with the answers here, because just for the sake of time. Okay, I don't want you to have a 15-minute video here. Okay, part E, the probability that z is greater than negative 1.28. So we'll make the curve, and we'll shade it to the right of negative 1.28, because greater than negative 1.28 shades to the right. But again, the problem is when we look up negative 1.28, we're going to get an area to the left of negative 1.28. Okay, so that's going to give us this area where my finger is. Okay, we don't want that area, so we have to do 1 minus when we look it up. Okay. So when you look up negative 1.28 in the tables, you get 0.1003. And I'll just show you that real quick because I didn't do a negative one with you yet. So looking up negative 1.28, so negative 1.2 is here, and then the nearest hundredth is 8, so that's this column. So we go down, and it looks like right here. Okay, so negative 1.28 for a z-score gives you an area of 0.1003 to its left. Okay, so the area to the left, this area here is 0.1003, so we want to subtract that from 1 to get the area to the right of negative 1.28. Okay, so when we do that, we get 0.8997, and then again, normal CDF, the left z-score, negative 1.28, and then going to the right, we'll go to positive 100 and get the same answer. Okay, so once you get the hang of that, that shouldn't be too bad. Okay, so you may need to go back and look at those again. But we're going to go on to the next page. Okay, and the next page, it may seem like it's going to be more confusing, but it's actually going to be fairly easy, especially on the calculator. Okay, so what we're looking at, the probability that z is between negative 1 and positive 1. Okay, well, when you do that, okay, what we're basically looking at is our normal curve. 0's in the middle. We'll say negative 1 is there, positive 1 is here. So we're looking for that area in the middle. Okay, and again, that's z. Okay, well, when you look at the normal curve, we know from the empirical rule between negative 1 and positive 1, we know that we had 68% of the data. Well, let's see how that plays out in the chart. Now, this one in the chart is a little more confusing because when you look up negative 1 in the chart, that'll give you the area from here to the left. Okay. So if we do that, let's look up the z-score for negative 1, and we'll see how this all comes together here in a second. Okay, if we look up negative 1.00, so negative 1.00 is 0.1587. Okay, so let me put that down. 0.1587. Okay, so that's the area to the left of negative 1. And then if we look up positive 1 for the z-score, that'll give us the area from positive 1 all the way to the left. Okay, so let's look that up and then we'll explain what happens. So when we look up positive 1.00, there's 1.00, so 0.8413. Okay, so let me write that down. Okay, basically what we have is we have from 1 to the left is 0.8413 area. From -1 to the left is 0.1587 area. What we're looking for is this missing area in the middle. Well, how do you find what's missing in the middle? Okay, to find all this space in here, okay, or all the space up here, I should say, to be a little more accurate, to find all that probability, well, you look at what's missing to get from 0.1587 all the way to 0.8413. So what's missing in there is the difference between the two. So if you subtract 0.8413 minus 0.1587, you're going to get what's left over in the middle. Okay, now another way to look at that in an easier way, using easier numbers, let's just say you had a rope. Okay, let me draw it down here. Suppose you have a rope that was, say, 3 feet long. Okay, so from here to the end is 3 feet long. If you know from here to here is 1 foot, what's missing? Well, the area from here, or the distance from here to the end would be 3 subtract 1, or from there to there is 2. We're doing the same thing here. We're taking the larger area, so from 1 to the left, 0.8413, minus the smaller, 0.1587, and that'll give us the solution. So we're going to do the probability that z is less than 1 minus the probability that z is less than -1. Okay, so we're taking to the left of 1, subtracting the area to the left of -1. And that was 0.8413 minus 0.1587, which is 0.6826. Okay, so there's our answer. Now the empirical rule said 68% between -1 and 1 for the z-scores, or within 1 standard deviation of the mean. Well, it's actually 68.26%. Okay, about 68 is what we round to. Okay, now as far as the calculator goes, if you do normal CDF, the left z-score is -1, the right z-score is +1, and that's why I said earlier it was actually easier to do this in the calculator, and that gives you 0.6827 when you do that. Okay, I'm not going to actually show you the calculator. You can do that. Okay, which again is only 0.0001 off from the charts. Okay, if we continue on with this, the probability that 0 is less than z is less than 1.54. Okay, again, we're going to make a diagram, and again, for the sake of time, I'm going to just put up here. If you want to pause and try it yourself, then go ahead. Okay, but I'm going to go ahead here. Okay, so we draw the z-score, so from 0 to 1.54. So basically, we're going to take the area to the left of 1.54, subtract the area to the left of 0. Okay, and that's what that's telling us. So to the left of 1.54 had an area of 0.9382. To the left of 0 has an area of 0.5. So subtract those, you get 0.4382. Okay, and then there's the calculator instructions. Okay, moving along to the next couple. Okay, and again, this is where I'm going to say that if you want to pause the video and work on these yourself, you can. I'm just going to put the answers up there just for the sake of time. Okay, then I'm going to move along to the next part here. Okay, question number 4. We're going to go back to the wait times at a busy restaurant being normally distributed. There's a typo there that should say the mu, or the mean, is 30 and the standard deviation of 6. Okay, so this goes back to the example that we did in the last video. Okay, now let me get this. Let me get my paper back here. Okay, and what we're going to find, the probability that x is less than 33. Okay, now this, you have to be careful with because you may notice that it's asking you the probability that x is less than 33. It doesn't give you a z value there. Okay, so we're going back to this distribution. Okay, and we want to find the probability that x is less than 33. Okay, so the probability x is less than 33 right there. Okay, we're going back to this distribution. And 33, we said before, would have a z-score of 0.5. Okay, now we're going to go through the actual steps of how to get that. Well, the probability of x being less than 33 equals the probability, when you look at how you convert 33 into a z-score, we're going to turn x into z, so the probability that z is less than, well, the way we turn x into z is to use x minus mu over sigma, which will be 33 minus the mean over the standard deviation. So that equals the probability that z is less than 3 over 6 or 0.50. Okay, so what we're looking at on our diagram, or on a graph of our normal curve, if we're looking at our standard normal distribution, okay, with our z-scores, well, a z-score of 0.5, I'll just say it's right about there. So there's a z-score of 0.5. In terms of x, remember what that would mean on a separate axis for a random variable x, which was the wait time. A z-score of 0 was a wait time of 30 minutes. A z-score of 0.5 is a wait time of 33 minutes. Okay, now what we're trying to find is the probability that x is less than 33 minutes or z is less than 0.5. So we locate that on our diagram. Less than, we're going to shade to the left. So we're trying to find that area. Now we should recognize that this is going to be greater than 0.5 because, maybe I should say 50% to not confuse it with this 0.5. But the probability or area is going to be larger than 0.5 because that would be, or 50%, because that would be to the left of 0, 50%. We have more area to cover. Okay, so if we look up 0.50, okay, for the z-score. So positive z-score of 0.50, okay, that takes us to 0.6915. Okay, so 0.69. If we use the calculator, we would say NormalCDF. We're going to the left now, so the left z-score is negative 100, and then comma, the positive z-score is 0.5. Okay, don't put 33 in because that's an x value. Okay, we want to put the z-score in 0.5. Okay, and that'll give us 0.6915. Okay, and then the next one, the probability x is less than 40. Okay, so again, what we'll do is we'll convert the x into z, and the way we do that is x minus mu over sigma. So 40 minus 30 over 6. So that equals the probability that z is less than 10 over 6, which is 1.67. Okay, now we're rounding that to the nearest hundredth because in our tables, that's what we can look up in our table. Okay, to the nearest hundredth for the z-score. Okay, so our diagram, okay, I'm just going to go right to my answer sheet here. Okay, the diagram, okay, will look like this. And again, this will be 30 minutes and 40 minutes as an x value. And you get 0.9525 if you look it up in the tables, or if you do the normal CDF with negative 100 comma 1.67, you get 0.9525. Okay, moving along to the last page of this. The probability that x is greater than 35. Okay, so hopefully what we've seen now is that when you want to find the probability of x being greater than, less than, okay, whatever the case may be, when you're looking at that x, you need to convert that into a z and then find the probability. Okay, so what I like to say is you go from x to z to probability. Okay, so we'll convert the x into z by saying the probability that z is greater than, well, x minus mu will be 35 minus 30 divided by 6. Okay, so when you do that, let me find my answer key for that. Somewhere here. Okay, you get the 0.83. Okay, so the z-score is... Now in this one, we're saying that x is greater than 35. So that's the probability that z is greater than 0.83. So remember, a greater than, we're shading to the right on the curve. Well, when you look up the area, that finds the area to the left. So that means you have to use the complement, or 1 minus the probability that z is less than positive 0.83. Okay, so we look up 0.83 as the z-score. That gives us the area 0.7967 to its left. And again, what that area represents is the area over here is 0.7967. So the area to the right is 1 minus that, which is 0.2033. And then again, there's the calculator instructions. Okay, the next one. Now, we're looking at the probability that x is between two values. So we're going to turn x into z, and we're going to turn 35 into a z-score and 45 into a z-score. So, I know it looks really confusing, but we're using x minus mu over sigma each time. So 35 minus 30 over 6, and 45 minus 30 over 6. Okay, and that gives you the probability that z is between 0.83 and 2.50. Okay, so then, again, I'll just show you the answers here and explain the way through it. If you want to be between two numbers, this is where you subtract the area to the left of 2.5, okay, which is the probability that z is less than 2.5, minus the area to the left of 0.83, okay, which is the area to the left of 0.83 right here. So when you look them up in the tables, you get 0.9938 minus 0.7967. Okay, again, on the calculator, that work becomes very easy. You put the left z-score, right z-score, and you get the same answer. Okay, moving along. The probability that a wait time is between 20 and 30 minutes, well, that's just like the last question. Okay, so again, if you want to pause this and figure it out yourself, go ahead. Okay, I'll just go through and show you the answer for the sake of time. We're getting kind of long here. Okay, so you convert the 20 and 30 minutes both into z-scores by using x minus mu over sigma. So that gives you negative 1.67 and 0 for the z-scores. So you want to find the area in between negative 1.67 and 0. So the area to the left of 0 is 0.5. The area to the left of negative 1.67 is 0.0475. And you subtract those. Okay, so again, once you get the hang of this, hopefully it isn't too crazy. Okay, then the last question. Would it be unusual for someone to wait more than 45 minutes? And explain. Well, there's two ways to look at something that is unusual. Okay, unusual means more than 2 standard deviations from the mean, or a probability of less than 5%. Okay, so if we find the z-score for 45 minutes, okay, that's x minus mu over sigma. So you get 45 minus 30 over 6, which is 2.5. Okay, so 2.5 is more than 2 standard deviations from the mean. So that means 45 minutes is more than 2 standard deviations from the mean. Okay, so a z-score larger than 2 will be unusual. Okay, so that takes care of finding probabilities given a random variable x. And again, the key on these is the idea of going from x to z to probability. If probability that x is less than something, greater than something, in between something, then you have to turn those x's into z's into probabilities. Okay, and the basic concept there is that when you look at trying to find a probability with a normal distribution, you have to use z-scores. Okay, we don't have a table where the mean is 30 minutes and the standard deviation is 6. We don't have another table for a mean of 30 minutes and a standard deviation of 4. Okay, there'd be an infinite number of tables. And that's the power of normal curves, is that no matter whether you're dealing with heights of men, weights of men, ages of cars, wait times in a restaurant, if you know they're normally distributed, that means you can always convert those random variable x's, the actual height, the actual wait time, the actual age of a car. You can convert those into z-scores and then always find the probabilities using your tables. Okay, so that takes care of that. And there'll be one more lesson.